Welcome to All This Math. This is Professor Parker, and today we're going to be talking about the Triangle Inequality Theorem. It's just one of those geometric theorems that, we just use at different times to solve different problems. And let me do this though. Let me take it out of the textbook and put it into the real life scenario, right? So why do I need to know the Triangle Inequality Theorem? Or why would that matter to me? Okay, I'll give you one example. This is one example why you would want to know and understand at least the concept behind the Triangle Inequality Theorem. All right, check this out, right? Let's say, you have a home and you want to get something built in your home in the shape of a triangle, right? But you don't want it to be an equilateral triangle, which means your triangle has three equal sides, or all three sides of the triangle are the same. You don't want it to be, well, it might be isosceles, but anyway, let's say, look at example one. Let's say you want a triangle that's got, or you want to build something that's in the shape of a triangle. That triangle has three sides, and then one side is like 15 inches, another side is 12 inches, and the third side is 19 inches. Now, you might not know, you might just be assuming like, okay, yeah, I can make a triangle. I know what a triangle is. A triangle is a polygon. It's got three sides. They all connect, right? All right. But you don't know if based on those measurements that that's actually going to be a triangle, because it's possible that you could be trying to construct something that does not exist. Meaning you could be trying to construct something that, where the third point will not connect, right? It just won't connect. Like you might be trying to draw something that looks like this. Boom, boom, boom. You see that right there? That's not a triangle because this point does not reach this third side. That's not a triangle. So how we use the Triangle Inequality Theorem is to measure and know, okay, is this actually going to even be a triangle? All right? Because I always want to put that out there because like a lot of times people be talking about like when I'm going to use this stuff, this ain't relevant to real life. Like, it ain't relevant to everybody's real life, but it's relevant to somebody's real life. So maybe the better question is, what type of life do you want to live? Because based upon what type of life you live will then determine whether the math that you see is relevant to you or not, or whether it will be relevant in the future. But anyway, let's dig into these problems. So what will typically happen is like in a geometry class, right? If you're covering the Triangle Inequality Theorem, you'll be given like a question like this. Do the following lengths represent the legs of a triangle? Or are these three numbers the sides of a triangle? Or something to that effect. And you'll be given three numbers, and then your job will be able to tell, okay, does this represent a triangle? Or can these be three lengths of the sides of a triangle? All right? Can they be? This is how you do it. And the Triangle Inequality Theorem basically says this. In any triangle, all right, I want you to focus on this, right? In any triangle, if it is a triangle, the sum of any two sides has to be greater than that other side that's left out. I'm going to say it again. The sum of any two sides. Now, understand what the word sum means. That means when you add things together, right? That's the result you get when you do addition, a sum. The sum of any two sides of the triangle must be greater than the third side. If that ever does not happen with any two sides that you pick, then that thing is not a triangle. It could be something, but it ain't a triangle though, because a triangle is a polygon that has three sides that all meet at vertices. All right. So this is how we do the problem. Let me show you. Okay. I know the suspense is killing you right now, right? So I got three sides. Now again, Triangle Inequality Theorem, it says any two sides, the sum of any two sides must be greater than the third side. So I start out like this. I do 15 plus 12, and I set that inequality up. So then I ask myself the question, is this true? Because math is all about finding the truth. It's either true or it's not. 15 plus 12, I know is 27. Is 27 greater than 9? Yes, it is. All right. So that's one pair of sides. But then I go over here and I say, okay, well, what about 12 and 19 though? What if I add 12 and 19? Is the sum of 12 and 19 greater than the other side, 15? Let's see if this is true. 12 plus 19 that's 10 and 10 is 20 and 11 is 31. Is 31 more than 15? Yes, it is. Okay, so it works for that pair of sides. Now, but there's another pair of sides. What if I put 9 and 15 together? And I'm saying, okay, is 9 and 15 greater than 12? What's 9 plus 15? 9 plus 15 is 24. Now the question for us, is 24 greater than 12? Yes, it is. Now, when that happens, when all three pairs of sides within the triangle are greater than the other side, right? That means that these measurements represent the legs of an actual triangle. These measurements represent the legs of an actual triangle. And that's how we use the Triangle Inequality Theorem. That's really all it is to it. You got to do that test, right? You got to test out, you got to find three pairs of sides, right? Three different pairs, right? Look how I did it. I matched up the 15 and the 12, and then I compared it to the third side. I matched up the 12 and the 19, and I compared it to the third side. I matched up what's going on? What's going on? Wait a second. Made a mistake, because this is not 9. This is not 9. This is 19. Oh, yeah, I'm tripping. This is 19. Oh, and this is supposed to be 19. But then the question is, does it make a difference, right? I made a mistake in my writing, but does it make a difference? Let's go back. Is 15 plus 12 greater than 19? Yes, it is, because 15 plus 12 is 27. 27 is greater than 19. I didn't mess up on this one. This one was cool. 19 plus 15 is still, that's even a bigger number. So yeah, it's still greater than 12. So look, that's what you got to do though. You got to do that. You set up, you look at each pair of sides, right? You take a pair of sides. You take a pair of sides, and then you want to compare that to the third side that was not included. And as long as in all three situations, you get a true statement, then that means that that set of sides represents the legs of a triangle. All right. Now let's go on to number 2. Watch this. I'm going to do 9 and 40. 9 plus 40. Is that greater than 41? Yes, it is, because 9 plus 40 is 49. And I know 49 is more than 41. Boom. Let's pick another pair of sides. What about 40 and 41? So if I add up 40 and 41, is that greater than 9? The other leftover side. Definitely. That's 81. 81 is more than 9 all day long. All right. Now the third pair. Third pair, we got 41 plus 9. Is that greater than 40? Yes, it is. 50 is greater than 40. All right. So that means that if all three statements, all three inequalities are true, then that means that we in fact have an actual triangle, right? If any of the statements are not true, that means that we don't have an actual triangle. All right. Now let's look on to number 3 and then number 4. Number 3. Let's do this. Let's say, okay, what's 23 plus 16? Is that greater than 7? Yeah. 23 and 16, that's 39. 39 is more than 7. Okay, cool. 1 down, 2 to go. Then let's say I do 16 plus 7. Is that greater than 23? Let's do the math on that. 16 plus 7 is 23. It is 23. So is 23 greater than 23? No, it's not. 23 is equal to 23. So if it's not greater than 23, then it's not a true statement. So this is not true. This is not true. So we already know these dimensions do not represent a triangle. So back to my original scenario when I was trying to make the real life connection. So if you trying to build something in your house or in your yard or in your garden or whatever, and it's shaped like a triangle, and whether you come up with the dimensions or whether a contractor comes to you or a landscaper comes to you or whoever, and they tell you like, yeah, I can hook you up a triangle, you know, all three sides are going to be different. One side is going to be 23 feet or not even feet, but let's say something small, right? 23 inches, and another side is going to be 16 inches, another side is going to be 7 inches. Bro, that's not going to be a triangle. It's not. We can do the math to prove it. Like, it's not going to be a triangle. It's not going to work. All right. So, and now another question. Do I need to even worry about doing the third pair? Testing out a third pair? I don't. I mean, I could do it if I just want to just feel like doing it. Right. But I don't need to because I already have proven that this is not a triangle. All right. So I've already answered the question. Do these 3 lengths represent the legs of a triangle? They don't. Because we know that 23 is not greater than 23. 23 is equal to 23. 23 is not greater than 23. All right. Now let's look at number 4. I got 20, I got 10, and I got 9. So I'm going to do 20 plus 10. Is that greater than 9? Yes, it is, because 30 is greater than 9. Boom. So that's cool. Then what about 10 plus 9? 10 plus 9, is that greater than 20? Oh, whoa, hold up. That's not looking good for the home team. 10 plus 9 is 19. 19 is not greater than 20. 19 is not even equal to 20. So now we got an example where we have a sum that's actually less than the third side, right? So 19 is less than 20, right? 19 is less than 20. All right, 19 is less than 20. So again, we don't even need to check the third pair. We don't need to do that. We already know that this is not a triangle. So just to recap, we see what happens. This is how we use and actually apply the triangle inequality theorem. So in number one, this was a triangle because our three inequality statements are true. Number two is a triangle. Our three inequality statements are true. Number three was not a triangle. One of our statements was true. One of them was not. I didn't even test the third one, right? And number four, same thing. One of our statements was true. Another one was not. So again, I didn't even test the third one. So there's that. That's the triangle inequality theorem. That's how you use it, right? There's a little more to it. There's some other problems that we can do. We can find out like an inequality that represents the range in which the length of the third side could be if you're given two sides of a potential triangle. But we're not going to get into that right now. I just wanted to set you up and start you off with this, just so you'll have some idea, about how to use the triangle inequality theorem and what it means. So if you learned something, please like the video, share the video, tell some people about it, text somebody, copy the link and send it to somebody, send it to a lot of people, and subscribe to the page if you haven't already. All right, peace. Thanks for tuning in.